Hello everyone, this is Vijetha, Associate Professor in the Department of ECE from MLR Institute of Technology. Today I would like to talk on practical inverting amplifier and non-inverting amplifier from linear and digital integrated circuits. These are the overviews which I wanted to discuss in this video. First one is the gain of a practical inverting amplifier, and next one is to determine the gain of a practical non-inverting amplifier. This is an equivalent circuit of a practical inverting amplifier. From this equivalent circuit, we would like to determine the gain of a practical inverting amplifier. So, to determine the gain of a practical inverting amplifier, you need to know what is gain. Gain is determined as ratio of output voltage by input voltage. So, you need to get the complete equations in terms of output voltage and input voltage. So, first I will consider this arm and I will write this equation as V0 is equals to I into R0 plus A into VID. And from this equation, from this arm, I will write VID is equals to I into RF plus V0. So, if you can substitute VID plus I into RF plus V0 is equals to 0. So, VID can be given as minus IRF minus V0. So, substitute this VID in the above expression. We can write V0 is equals to I into R0 plus A into minus I into RF minus V0. So, you can write V0 is equals to I into R0 minus A I into RF minus A into V0. So, if you can get all the terms towards V0 terms towards the LHS side, you can write V0 is equals to 1 plus A is equals to I common. If you can take I common, you can write I is equals to R0 minus A into RF. So, you can write I is equals to V0 into 1 plus A divided by R0 minus A into RF. Now, by applying KVL across this arm, you can write this expression as VI is equals to I into R1 plus RF plus V0. Substitute I in this expression, you can write here as VI is equals to V0 into 1 plus A divided by R0 minus A into RF into R1 plus RF plus V0. So, if you can simplify this expression, we can write VI into R0 minus A into RF is equals to V0 into 1 plus A into R1 plus RF plus V0 into R0 minus A into RF. So, the gain is V0 by Vin. So, you can rewrite this expression gain as V0 by Vin as R0 minus A into RF divided by 1 plus A into R1 plus RF plus R0 minus A into RF. This again, if you can simplify this, this equation can be given as gain is given as A is equals to R0 minus A into RF divided by R1 plus RF plus A into R1 plus A into RF plus R0 minus A into RF. This positive ARF minus ARF will get cancels out, and you can write this expression A as A is equals to R0 minus A into RF divided by R1 plus R0 plus RF plus A into R1 into 1 plus A. If as A is equals to R0 minus A into RF divided by R0 plus RF plus R1 into 1 plus A. In the numerator part, if I am assuming A is much greater than 1, you can neglect R0 and you can write A as minus RF by, and here I am considering R0 by RF is much greater than R1 into 1 plus A, and again you can write as A into R1. So here A into minus RF, and in denominator part you can write A into R1 and this gain get cancels out, and your A, that is gain, can be approximated to minus RF by R1. So the gain of a practical inverting amplifier is given as minus RF by R1. Next, this is a Thevenin's equivalent circuit of a practical inverting amplifier. From this circuit, you can determine the input resistance, which is given as RIF. RIF can be determined, and it is given as RIF is equals to VID divided by this I1. And I1 can be given as our this equation, and we can determine this VID by I1 by applying a KVL across this, and you can write across this. We can write this equation as VID plus I1 RF plus RF plus this R0, I1 into RF plus R0 plus A into VID is equals to 0. By applying a KVL across this, you can write as VID plus I into RF plus R0 into I1 plus A VID. This is a Thevenin's equivalent circuit for a practical inverting amplifier. From this equivalent circuit, you can determine the input resistance, which is given as RIF, which you can write it as VID by I1. And you can get the relation between VID and I1 by applying a KVL across this loop. So you can write here as VID plus I1 into RF plus R0 plus A into VID is equals to 0. So you can write this expression as VID into 1 plus A is equals to I1 into RF plus R0, and VID by I1 is given as RF plus R0 divided by 1 plus A. So input resistance RIF is given as RF plus R0 divided by 1 plus A, with gain is given as minus RF by R1. And the next one is from this circuit. This is an equivalent circuit to determine the R0. So from this circuit, you can determine the R0 by, see, from this circuit, you can write R0F is given as VOC divided by ISC. And this open circuit ISC, short circuit current, can be given as ISC is given as I1 plus I0. See, I1 plus I0. And here I1 can be given as VI divided by R1 plus RF, and I0 is given as A into VID divided by R0, and VID is given as minus I1 into RF. So by substituting VID as minus I1 into RF, you can write ISC is equals to VI by R1 plus RF plus A into minus I1 RF divided by R0. If you can take the LCM here, you can write R0 into VI plus A into R1 plus RF into minus I1 into RF divided by R0 into R1 plus RF. Here I1 into R1 plus RF can be given as VI. So you can rewrite this ISC as R0 into VI plus A into, minus, if you can take minus common, minus A into VI into RF divided by R0 into R1 plus RF. So you can finally write this short circuit current ISC is equals to VI into R0 minus A into RF divided by R0 into R1 plus RF. And we know that gain is given as output voltage by input voltage. So VOC can be given as A into VI. So just substitute VOC and ISC in equation 1. You can write output current ROF is equals to VOC is A into VI divided by VI into R0 minus A into RF divided by R0 into R1 plus RF. If you can cancel this VI, you can write the output resistance as A0 into R0 into R1 plus RF divided by R0 minus A into RF. This is the output resistance of a inverting amplifier, practical inverting amplifier. The next one is how to calculate or how to determine the gain for the circuit which is a equivalent circuit for non-inverting amplifier. This is a equivalent circuit of non-inverting amplifier. For this equivalent circuit, we need to determine the gain. So if you want to determine the gain, first you need to analyze the circuit. So the complete equation should be in terms of input voltage and output voltage. The gain is given as A is given as V0 by V in. So you need to determine the complete equations, complete expressions from the circuit in terms of V0 and V in. So for that, first I will apply a KCL across this node A, and again I will apply a KCL across the output side. So if you apply the KCL at node A, if you can apply a KCL at node A, you can write this expression as VI minus VID into, I am writing this in terms of admittance. So VI minus VID into admittance of R1 is Y1 plus VID into the admittance of RI is admittance of RI is YI plus for this arm you can write it as VI minus VID minus V0 into YF is equals to 0. If you can write these expressions in terms of voltage, you can write this as VI into Y1 minus VID into Y1 plus VID into YI plus VI into YF minus VID into YF minus V0 into YF is equals to 0. So this expression can be given as, see, if you can take VID common minus VID, I am taking common and I am writing it as Y1 plus minus VID plus YF minus YI, these three I have taken common from these three, plus if you can take VI common, you can write as Y1 plus YF is equals to V0 into YF. You keep this expression aside, this you got in terms of V0, V1 and VID, you let it be equation 1. Now, if you can apply KCL at output node, you can write this as VI minus VID minus V0 into YF plus AVID minus V0 into Y0 is equals to 0. So from this expression, if you can take, if you can write this expression in terms of voltage, you can write it as VI YF plus VID. If you can take VID common, you can write it as A minus 1 is equals to V0 into YF plus Y0. VID A naught A minus, you will be getting here as a YF A Y naught minus, I will rewrite this expression. So, by applying a KCL at node, output node, you will be getting it as Vi minus VID minus V naught into YF and A VID minus V naught into Y naught. So, if you can expand this Vi into YF minus VID into YF minus V naught into YF plus A VID into Y naught minus V naught Y naught is equals to 0. So, here if you can take Vi into YF, you can write this directly, and if you can take a VID common plus VID common, then you can write as A into Y naught minus YF is equals to V naught into Y naught plus YF. So, this equation you can write in terms of VID as how VID into A Y naught minus YF is equals to V naught into Y naught plus YF minus VI YF. So, VID can be given as V naught into Y naught plus YF minus VI YF divided by A Y naught minus YF. So, you got the expression as VID as V naught into Y naught plus YF minus VI into YF by A Y naught minus YF. If you can substitute this VID in equation 1, let it be equation 2. If you can substitute equation 2 in equation 1, you can rewrite this as, you can rewrite the expression 1 as, equation 1 is minus VID into Y1 plus YF minus YI plus VI into Y1 plus YF is equals to V naught into YF, and we got VID as V naught into Y naught plus YF minus VI YF minus divided by A naught Y naught minus YF. So, now after substituting this VID in this expression, you can write it as V naught into Y naught plus YF minus VI YF divided by A naught Y naught minus YF into minus Y1 plus YF minus Y1 minus YF plus YI plus VI into Y1 plus YF is equals to V naught into YF. If you can expand this expression as V naught into Y naught plus YF minus VI YF into minus Y1 minus YF plus YI plus VI into Y1 plus YF into A Y naught minus YF is equals to V naught into YF into A Y naught minus YF. If you can solve this expression, if you can get this expression in terms of V naught by V in, which will be like A into Y naught into Y1 plus YF minus YF YI divided by 1 plus A into Y naught YF plus Y1 minus YI into YF minus Y naught. This is the gain of a non-inverting amplifier. So, today in this video, I have discussed the gain of a inverting amplifier, How to determine the gain of an inverting amplifier using KCL and KVL in a equivalent circuit of inverting amplifier, and also determine the input resistance and output resistance of an inverting amplifier, and determine the gain for a non-inverting amplifier from equivalent circuit of non-inverting amplifier. Thank you.